Thanks. Is it, yeah. Okay. So sine theta equals 1. So that means we are looking for theta. We are looking for the angle. So I am not going to write it every time in the inverse, but this is the same thing as if we wrote it as sine to the negative 1 power of 1 equals theta. So the inverse is just a way to find your angle. So you're given the ratio, you want to find the angle. So the first thing we're going to do is draw a blank graph. And then we're going to figure out what our y and our r value are. Because sine is y over r. So y over r will be 1 over 1. Why is r 1?
Because it's always 1.
Yeah, if it's not a given ratio, it's going to be 1. Also, the only way for it to reduce to 1 would be 1 over 1. So then, we're going to reference our circle. So, when we are dealing with 1s and 0s, we're most likely looking at a quadrantal, so the orange lines. So we want to know when y is 1.
Pi over 2.
Good. At pi over 2, we have the point 0, 1. So y is 1. And we know that any of the quadrantals are r is equal to 1. So that point is going to fit that criteria. Y value of 1 and r value of 1. So I like to use highlighter. You don't have to. So that means we're looking at this angle, pi over 2, because that top point is 0, 1. And our r is always 1 for the quadrantals. Therefore, we are looking for our angle, so we're going to say theta equals pi over 2. And that's our answer. Take a picture and give it back because I'm using it. Okay, theta equals pi over 2. Okay, so the next one, so I'm just going to give you a little spoiler. 1, 2, and 3 are all going to be quadrantals because undefined can only come from the quadrantals because that means you're dividing by 0, and negative 1 and 1 also mean we're looking at quadrantals. The other option would be if it was 0. So cosine theta equals negative 1. So I'm going to draw my graph. Cosine is x over r. So that's negative 1 over 1. How did I know that the negative 1 went with the x? Perfect. R is never negative. Okay, so we need to look at our unit circle. Y'all are killing me. So we need to look at our circle and we need to find when x is negative 1. So the only time that happens is at pi. Do you agree? I'm just gonna go on with life right now. Right? Now everyone will want to go watch it, right? Okay, so at negative 1, 0, it fits the criteria of x equals negative 1 and r equals 1. So our theta is equal to pi. And that's our answer. If you have questions, you can ask them, as long as they're appropriate. I hate that I have to say that. Okay, last one on the top. Tangent theta equals undefined. So the only way to get a ratio that's undefined is if you have 0 in your denominator. Moved over. So The only reason we would have 0 in the denominator is if our top was 1 or negative 1. So our y over x is equal to 1 over 0 or negative 1 over 0, because both of those will reduce to undefined. So when we go look at our unit circle, there are 2 spots where that fit the criteria, where y is 1 or negative 1 and x is 0. So at pi over 2 and at 3 pi over 2. So that's here and here. So at 0, 1, and 0, negative 1, we match our criteria. So our theta has 2 answers at pi over 2 and at 3 pi over 2.
So if it's undefined, it's gonna have 2 answers.
Yes. I'm going to say yes. Okay, so undefined, negative 1, positive 1, or 0, be looking at the quadrantals. Then when we get down here, where we have ratios that kind of look similar to our special triangles, we're going to actually be drawing triangles. So, root 2 over 2, we've talked about that in 2 parts of the notes. If we looked at that, that would be y over r, and there's no y values for our special triangles that are root 2. So that means we have to go and rationalize the numerator by multiplying top and bottom by root 2 over root 2. So root 2 times root 2 is 2. And then the bottom will be 2 root 2, which is reduced to 1 over root 2. And now you have stuff that will match the special triangle. So if you would have tried to solve it without doing that, you would have seen pretty quickly it didn't match anything. So now we need to look at sine, which is y over r. And that's y over r equals 1 over root 2. So here's where you need to think about what quadrants are y's positive in. 1 and 2. So y is positive in 1, and y is positive in 2, so we're going to have little cat ears. Uneven. Okay, so then I'm going to label my sides that I'm given. Okay, so at this point, finding the quadrants tells us what we're going to be looking for in our unit circle. The side links that match a reference triangle is telling us that's not reference triangles, is telling us which angles we're looking for in those quadrants. So a y value of 1 and a r value of root 2 matches the pi over 4 reference triangle.
So that's theta.
So I like to write down my reference triangle because it helps me when I look at my unit circle. So it's almost theta, Tyler. So if you look here in quadrant 1 and 2, our answers are going to be the thetas that have pi over 4 in them. So in quadrant 1, it's pi over 4, but in quadrant 2, it'd be 3 pi over 4. So those would be your answer. So theta equals pi over 4 and 3 pi over 4.
Does it matter which way you put it?
I am not picky. I am going to be picky if you don't put theta equals, though. Okay, next one, sine theta equals negative 1 over 2. So those are proper side links, so we don't need to do anything different. We just need to identify our y value and our r value. So which value is the negative going to go with? I think I heard a distant y. So that means y is -1 and r is 2, because like you said before, r can never be negative. So what quadrants is y negative in? 3 and 4. Good job, Ireland Miller. It's on video. Okay. So we have a y value of -1 and an r value of 2. So next step, go look for which reference triangle that matches. So y value of 1, r value of 2 matches the pi/6 reference triangle. You don't have to write what the reference triangle is, it just helps me. Then I go look in my quadrants 3 and 4 and find the ones that have pi/6 in them. So 7 pi/6 and 11 pi/6.
Wait.
I'm waiting.
Okay. Wait.
Thank you. Okay, for now I'm going to skip number 6. If we have time, we'll come back to it, and I will post the entire key online.
How come
Why wouldn't 4 pi/3 and 5 pi/3?
So it's after it's reduced. So once it's reduced, we're looking for that to match.
Can you?
Yep, good question.
Do the second one on the bottom,
Yes,
cosine and sine?
yes. Okay, let's start here just so we make sure we cover one that looks like this. So we have cosine of arc sine of -1/2. So what you need to look at first is this inside part. Arc sine of -1/2. And remember that arc sine is the exact same thing as sine to the power of -1. It's just saying inverse sine. So we're first going to deal with the inverse sine, and when we're looking at principal values, that's when we're looking at our moons. The little like half moons. So principal values, we're looking at our moons. So I'm going to draw the moon that matches sine, which is the right hemisphere. I'm going to make it that. So remember that when we're looking at our moons, or half circles, whatever you want to call them, it's just lining up with the unit circle. So if we're looking at the right side, that means we're looking at this side of the unit circle. Then, sine, so I'm just looking at this stuff right now. Sine is y/r. So that means our y is -1 and our r is 2. And we are just looking at quadrant 1 and 4. So we need the quadrant between 1 and 4 that matches this criteria. So y is only negative in quadrant 4. So that's where our triangle is. And we're going to write our side links. -1 is our y. 2 is our r. So the first thing you need to check and see is if it's a special triangle. So if it matches a special triangle, we don't have to find the other side length, we just match it. So this one has a side length of 1 and 2, or a side length of 1 and a radius of 2. Therefore the x is √3. Okay, if we were not given side lengths that matched a special triangle, you're going to use Pythagorean theorem to find the other side length. I'm listening.
Why is the answer square root of 3/2?
I got you. Okay, so we have done this part. That part is taken care of. Now we need to find cosine using this data. So cosine is x/r. So our x value with this data is √3. And our r value is 2. So our answer to the whole thing is √3/2.
That was the correct.
Is it theta?
Oh.
Miss Stone,
What?
you have to put theta in front of it.
Theta equals.
Theta equals.
We're just going to leave it like that for now.
Okay.
Is there a difference on the
It's writing an equation. But we're just gonna leave it like that. You found the ratio, x over r. Okay, so the hardest thing about these is depending on what's inside is what you're gonna do first. So on this next one, cosine to the power of -1, so that's inverse cosine of tangent of 7 pi over 4. So now we're not given a ratio like we were up here. 7 pi over 4 is an angle. So we're given an angle, and we're also not using inverse tangent. We're just using regular tangent inside. So this is what we're doing first. So this is giving us a theta, and we're going to use that first on a graph. So tangent of 7 pi over 4. So pi over 4 and 7 pi over 4 are going to be matching side lengths. And 7 pi over 4 is in this quadrant. So I'm just going to draw my triangle and mark my side lengths based on my unit circle. So 7 pi over 4 is in my fourth quadrant, and pi over 4 has the side lengths of 1, 1, and root 2. And so the y value, like I heard someone say, needs to be -1 because we're going into the fourth quadrant. I did it differently on my key. Then we have marked our tangent. Oh, so tangent, hold on, thinking.
Tangent's y over x.
Tangent's y over x. I'm just trying to see if it's relevant right now. So now we need to find inverse cosine using this data. So inverse cosine, and we're going to plug in our ratio to find, because whenever you use inverse cosine, you're looking for your theta. So we're going to plug our ratio in using our numbers. So cosine is x over r. I think this is the hardest one. Just wrapping your brain around it. So cosine is x over r, and using this data, x is 1, and r is